So we're going to dive right in. Again, my name is Alison Cossette. I work at Neo4j. I work in graph databases. Anybody here ever worked with a graph database before? Anybody who hasn't worked with but has been dying your whole life to learn another database and another query system? Yeah, there we go. Wow, that is a very unusual response, but I love it. This is great. What I'm going to talk to you today, so how many people here have already done some work with RAG? RAG in production? RAG in production that you wish you were getting better outputs or knew how to manage your actual RAG data set? Anyone? Yeah. So mostly what I'm going to talk to you about today is ways that you can leverage a graph specifically, but really look at the dynamics of the data inside your graph system and how you could use, say, your telemetry to understand more about how your system is doing and how you can improve the data that's going into it. Obviously, we all know what RAG is, right? We've got our LLMs. We want them to be better. We bring extra things in, right? Most of us are primarily using a vector database of some kind. There have been a bunch of different talks today. If anybody saw Andreas Kolliger talking about his agentic RAG or his graph RAG, he's done a couple of talks today. Another talk for another day is actually leveraging a full knowledge graph for your system. So there's lots of ways that you can do that. But so I'll talk to you a little bit about what is a graph and what are graph components for those of you who are new to it. When we think of the data structure that is associated with a graph database, we primarily start with what are nodes or entities. You can think of these often as the table names in a relational database. So in this case, maybe we have a person table and we have a car table. The other thing we do is we map the relationship. So normally in this instance, if you had people and cars, you'd probably have a lookup table where you have your people car table and it will have the person and then the car, because you have many people, many potential cars. It's not a one-to-one, your classic many-to-many. And in Neo4j, what we do is rather than having that lookup table, we represent it as the actual relationship. So the person drives the car, the person owns the car, two people who know each other, right? Like, one row has a relationship with another row. And the idea being here that we're looking to create a very efficient and a more representative view of the data that you have, right? You may be asking me, well, if I have a car table or a people table, there are many columns in that table. Those columns in this case would be represented as properties on that node, aspects of the entity. We also have properties on the relationship. So here, this person, Andre, has been driving this car since 2011. I imagine it has either many miles or he does not drive very often. But one of the things that you're going to see down in the car label or the car entity, the properties, you're going to see the description. And in that description, we see the embedding. Obviously, a lot of folks mentioned they're already using RAG, so you're probably using vector databases primarily. Yeah. Yeah. Some people might be using document databases with embedding capabilities. Anybody? Any Mongo plus vector folks in the house? Yeah, maybe. Well, at Neo4j, what we do is we allow you to take that embedding and make it a property of the entity. So in this case, it would be the description embedding on that description. And you might be asking me, Allison, like, that's all well and good, but what does this have to do with my RAG data set? I want to talk really briefly about knowledge graphs in general, and then we're going to dive deep into knowledge graph as it relates to managing your RAG data set. So when we talk about the knowledge graph, in this case, the first entity is the document, and then we break it up into chunks, which everyone is familiar with. One of the properties of that chunk is going to be the text itself. Another one of those properties is going to be the embedding. The nice thing about using the embedding as a property is if you decide that you want to have multiple embeddings because you have different applications where one uses, I don't know, GPT X and one uses, Sonnet or Claude or something else, you can have multiple embeddings on the same chunk. But the key here is that there's a relationship between that chunk and that document, right? We also want to look at, and what we're going to be talking today about, is using a knowledge graph for your tracking. And in this case, we're looking at the nodes of the application. The application I'm sharing with you and the data we're sharing with you is from our live production app that we have, which takes into account our graph data science documentation, and various pieces of our documentation to build a chatbot that our internal and external users use. Graphs do really well whenever you're tracking any kind of sequence, right? If you think about, like I always like to do the Waze or GPS to get from one place to another. There are many turns and many stops. So a graph is really helpful whenever you have some kind of sequence. And in this case, when we're thinking about AI interactions, it's clearly a sequence where we start with a prompt, we get an answer, we say, nice try GPT-5, but can you fix it this way, right? And so there's this back and forth. And in our RAG applications, we have the same thing. We start with a prompt, we pull in some documents, we get the response. And so everything that we're doing today is based on this element here. And it's based on how the actual application tracking connects to the data set itself. So we're really focusing on just these three pieces, which is the prompt, the response, and the chunk. Right? So anybody have any questions so far? Got a good idea of the basis of the graph that we're looking at today? Love questions, even though we don't have a lot of time. I always like to take them. So what does it mean to actually explore your RAG data set? As I said, this is something that we have that's currently in production. It's a number of different official documentations, our developer blogs, different knowledge bases that we have, our community, our GitHub. We then split this into, we used a 512 chunk size. How we went about building it. There's lots of ways that you can go about building it. But really, we end up with 15,000 embedded text chunks that are available to the system for this RAG application. So the first thing that, yes? Yeah, we do have a small overlap. I don't remember exactly what the overlap is. I think it's like 20 or 30. I can check on that for you afterwards. But yeah, I was big fan of overlap. The other thing that we have is, and we'll show you, is you can also have next relationships from one chunk to the next, so that if you want to pull in a larger piece on either side, you can do that as well. But one of the things that I come from the data science side. And so for me, when I look at our software applications, I'm always looking at how can the data give us a better outcome? And so one of the things that we did first is we just did some basic exploratory data analysis on the source documents themselves. And we saw this very weird, anomalous long tail of the text length. I don't know exactly what happened, but we certainly had an anomaly. So we had to fix that text length and make sure that we were within that 512 chunk. And so again, these seem like really straightforward things. But sometimes what you'll find as software developers, you don't always have the same sort of knowledge domain over what's going into the system. So just most of this is really just sort of a heads up on that side. So the big thing and the big philosophy here that we're going to talk about is this element here, and it's called Connect, Cluster, Curate. And these are the building blocks that are going to allow you to actually curate your RAG set at scale. The way that we do it is we do a KNN similarity. And so we actually create relationships between the chunks that are the most similar, right? That's the first thing we do. Then we look at this structure and we say, okay, are there clusters of documents? Are there areas? This is an algorithm with different algorithms we use for community detection in graph. And really what it's looking for is it's looking for a lot of heavily intertwined, heavily connected. So if you can imagine, if a lot of documents have very similar understandings, then there's going to be a lot of connection there. So we first connect the documents that are the most similar. Then we run community detection to cluster those documents. And then this clustering is going to be the basis for the curation and the way that we actually look at our documents at scale. Has anybody done anything like this where you've done any clustering on your RAG sets at all? No? This is new? Oh, you have. Somebody has. My overlap question, definitely has done this before. I love it. So it is just one way. Yeah, go ahead. We're clustering the chunks. Yep. Apology. Did I say? I apologize if I misspoke on documents. Yeah, we're actually clustering the chunks themselves. Yeah. So in this case, we use graph data science algorithms. We probably are using in this one, I think we're using a Louvain community detection clustering primarily. And really what it does is it looks for the areas that are the most interconnected. So do I have more connections to each other versus another set of documents? So you think of your own social networks are like that. You have a group of friends where you're all friends with each other, and then somebody else has a group of friends and they're all friends with each other. And maybe you have a little bit of connection between you, but you're mostly sort of in this crew or that crew. That's the analogous sort of easy version of understanding what's happening under the system. It has to do with modularity calculations and things like that. Yes, Peter?
Yes. Is it also not better to have hierarchical chunking? Because, for example, now you have fixed size chunking.
Yeah.
And if you have a chunk that's in the middle of a piece of text,
Mm.
and, for example, the text goes about maintenance, but only the title says it goes about Volvo.
Yeah.
Then the whole section, it goes about maintenance, but the model doesn't know it, so wouldn't that be better?
Yeah, so the art of chunking and the hierarchy, definitely, this is one of our first use cases that we put into practice. A lot of what we do is we actually connect to other structured data around like versioning, and then some of those hierarchies, which paragraph, which version, which document. So we have the graph of those as well. So to your point, yes, there are lots and lots of smart ways to do chunking. We address some of that more in the graph itself associated with those chunks rather than in necessarily the chunking process. But yes, you are absolutely correct.
All right, so then just for my own setting, so you first chunk it, then you go over it and add that as metadata.
So the way that it works is we actually have the chunk connected to the document, and the document contains the metadata. You can then, which you may have seen in some of what Andreas was doing, you can actually then extract structured text structure from that text. In this case, we're not looking at that. And the reason that we're doing it is a lot of people, they are already using a vector database, or they have some way. And so the idea behind what we're showing you today is regardless of how you chunked and what kind of your base RAG data set is, this is still a way that you can leverage that to understand the system itself. Yeah. Great. Thank you. Great question. So once we do this chunking, we actually look at it. We create like this, sort of 2D version of what our clusters look like. And one of the questions may be these are some zoom ins of our clustering, and you may be asking yourself, which of these looks better? Right? As far as my RAG data set is concerned, do I want this really clear, like this cluster is really clearly in this subject area, there's not a lot of sort of spread on it, or are we more interested in potentially overlapping clusters where the clusters aren't really clearly defined and they're kind of spreading out really semantically? Anybody have a guess of which one of these you probably would feel more comfortable with? Yeah, see, you sure you might want to come up and teach this class. And that's exactly the right answer, because if we have a lot of documents that are, a lot of chunks that are very similar and they're in the same space, is that helpful? Do we need 10 or 12 versions of the same element, or do we need to be able to return more variety? Most of the time when we're doing some sort of a RAG application, we have a K of whatever is coming back. So are you getting the right variety? And again, we're looking just at the chunk and the semantics of it. So how do we actually then use this information to curate? So obviously, the same principles that everyone is using when you're looking to build out your data sets. It needs to be relevant, actually needs to augment the answer. It needs to be reliable, and it needs to be clean and efficient. The clean portion comes in with some of your chunking styles, among others. But what we want to look at today is we want to look at, like, when we have this at scale. I know a lot of us are given masses of documents to say, put this into this application, let everybody use it, it's going to be great. Yeah, there's chuckling because it's true, right? They just give you all these things and you're not the subject matter expert on any of it. So you don't know what's the best hierarchy. You're like, all right, I'm just going to chunk and vectorize and like cross my fingers, right? So some of the things that you can do once you put in this clustering is you can start looking at the statistics of the clusters themselves. So for example, in this case, our cluster 7117, we saw that the median average word length was the length of the chunk, right? So we're like, okay, I don't know of any 512 character words, so something must clearly be wrong here. And so what we did is we went in and looked at it and we're like, oh, okay, right? I mean, we had things that came in from a lot of different places. And clearly this information probably wouldn't come up in your vector search, but more importantly, isn't helpful. So this is a way that we can help to clean out with just some very basic elements. The other thing, which, Peter and I were just talking about, is your highly similar text chunks. So what happens when we look at the community, right? So in this community, I mean, we made it a community because it was similar, right? So we're expecting to see some of this, but to what extent is it similar is the question. So in this case, we can see when we looked at the average similarity, so we have a pairwise similarity among every chunk in the cluster, and we started looking at the pairwise average was really high. So even like in this first one, we've got 17 nodes, we've got 17 chunks. Among them, there's 272 relationships, and the average similarity is 0.99. So, really good job on clustering, right? So like that works. They're very similar, but do we really need that many versions of the same thing? I was sitting down with some folks right before this, and we were talking about this very thing where they were looking at documentation for a RAG application. One person mentioned onboarding and another person was just talking in general. And you may have different pieces of the documentation that are the same across versions. In this case, it's about heterogeneous relationships, which goes across many of our algorithms. But when I think about like a K of 5, I want every one of those chunks that's coming back to be useful. So I don't necessarily need this many versions of an explanation of heterogeneous relationships in a graph database, right? But I do want to make sure that I know that that chunk is related with all these different algorithms and all these different URLs that are listed. So how do I manage the desire to have one and yet can retain the knowledge of the many? So the way that we do that in a graph is we have something called collapse. And in collapse, what it does is it says, okay, all of these are very similar. We're going to make that just one chunk. And we are going to retain the relationship from that chunk to all those original URLs and those original sources. So from an application perspective, two things happen. One, if you're doing any sort of pre-filtering on version or something like that, you're still going to have access to this chunk. And it really tidies up what comes back as far as the application itself is concerned. Yes?
What if there is semantic difference between the text? Or is the similarity then much lower?
Yeah, in that case, the similarity is definitely going to be lower. I mean, obviously, you never hurts to spot check, right? like take a look at it. But if you've got a similarity, I think our similarity across was 0.9918, right? I mean, and especially because we have a small chunk of similarity that high with, a really high dimensionality on the embedding, all that together means that pretty much what you're going to need is there. And again, it's always about your use case. Exactly. That's going to be there. We had another question.
Yeah, and I guess here they're all the same, but would it react the same way if they're nearly similar? same?
Yeah, I mean, I think that's where really, diving in and taking a look at what's actually in there is going to be helpful. You're going to know what that threshold is. Again, when we run this, we also run it with that metadata and with that graph knowledge. And so we have other pieces of context to additionally ground that. So you certainly want to look and see if there's something critical. I would, and again, this is like a gross generalization. I would imagine if there was something critical in there, then that made it semantically very different, then it's not going to have that same kind of numbering. And you can also set that threshold, right? Like you can say, I don't want the entire cluster to go to 1. I want to set a threshold of X, whatever that may be, and collapse from there. And but again, like very use case and domain knowledge specific.
I was wondering when you say we have, those are functions I get when I install Neo4j.
Yeah. So in this case, these are referring to the documentation of our algorithms that we have, and there's some standard language that we have around different pieces. So they're going to be repetitive, and we don't want those coming out in the application itself. So the other thing then that we want to look at when we look at like how can this graphing of these conversations and this document retrieval, what else can we learn? How else can we leverage this to continue to improve the applications that we've built? So in production, we want to understand how the LLM is using these documents, how they produce the answers are more important, become more and more important. And then really just logging these interactions and understanding what the system is doing. Had a really nice conversation earlier today as well with, in these AI systems that we're using, the importance of which data comes back and, how influential it is across a larger system becomes really interesting, right? So what does this end up looking like? So just as a reminder, what we're looking at the prompts, the response, and the chunks that they're associated with. So we can do some of the things that you could otherwise also do. So what are the most frequently used texts, right? What's coming back pretty often? For us, it's a centrality algorithm, which we know is one of, some of the biggest use cases that we have for our graph data science piece. When we look at these, again, from a clustering perspective, the first cluster is our documentation, but the next comes from Tomasz, who I know some people here have met, all of his work that he has done in community and in our blog sphere. So a lot of information is coming from those places. How this becomes helpful, it becomes helpful for a couple of reasons. One, it lets you know what are the documents that are coming back the most and where do we need to spend our time from a curation perspective. So if we know that, maybe something unusual is in our top 10, we don't put a lot of time into that, maybe we should. Or we have a large team that's spending a lot of time on this piece, and yet it's not necessarily as impactful for the RAG application. Maybe we can reallocate resources. So by understanding that importance and that influence, it allows you to have insight into how you want to actually manage the data set and where you want to invest time and resources. And this really, I think, is the most useful part for this conversation is like, okay, Alison, like numbers, EDA, whatever, what does this actually mean? What we're really doing here is we're tracking, first we see the user and when we see this conversation begin, and then the light pinks are the interactions that we're seeing in the application. So the user has a prompt and then we see the assistant return the answer. And the relationships from that answer are what those chunks were that were retrieved from that prompt based on that cosine similarity. And the numbering that we see on them is actually the cluster itself. So this person, primarily everything, this one happens to all be from the same, mostly, almost entirely from the same cluster, but we just start to look at where the conversation goes. So if we see the first prompt that they had pulled back these 10 documents, the second prompt pulled back 5 of the same, but 5 new ones. So what you start to be able to do is you start to be able to watch a conversation move around your data and around your clustering in your systems. So one of the things that we know is sometimes you want a longer conversation and sometimes you want a shorter conversation. And so how does this clustering help us understand what we're doing? So this is an example of one particular conversation, and it shows each of the different groups that the data came from. And so when the person asked the first question, it was primarily, I guess you can't see the group numbers on this. Most of the answers came from one area, like one cluster of documentation. And as the person continued the conversation, it started to travel into other areas of information. So they started out asking about whatever's in the blue cluster. They ended up primarily in the purple cluster. And now I want to know what they actually are. But where this becomes helpful from an understanding is, most of the time not most of the time, but sometimes understanding how people are using the RAG application can tell you different things. So if they ended up in purple, is it that they didn't know that that's what they were supposed to be asking about in the first place? Maybe it's an HR policy and they were asking about expenses, but it's really about something else. Or maybe it's a product question and they started asking about one capability, but the answer that they really needed was in the end. Most of the time, and just subjectively, what we find is the biggest topic at the end is usually what people were looking for when we're in this learning capability type of chatbot. And so, for us, it's like, oh, it took them a while to get there. Is it that we need more documentation about it? Do we need to put something out in the community, right? And this, again, is just one. We can actually look at these at a larger scale of seeing like where most conversations start and end. And that's one of the ways that we used it to say what areas of content might we need to fill in that, isn't being addressed, that people don't know what to ask. So documentation usage and the splits across the subject areas is another element that can be really interesting for understanding how the RAG is functioning at scale. The other thing that we look at is in general, the structure. Graphs are really good at giving sort of what I call the soft eye. So if we just look at this and don't dive into which cluster numbers and what they are, each of the light pinks is a chunk, the dark pinks are the responses. What we see is a lot of the questions are around this one area. So we can start to see that, oh, this is an area of high density. These grouping of chunks is where we have a lot of activity in the RAG application. So natural clusters start to form when we look at it in the structure itself. Getting to what I was mentioning earlier, the question around conversation length, in some instances, looking at your conversation length, if you're in social media, you want people staying on a long time. Like if you're, certain areas, for us, we wanted our users to be able to come in and get a question answered and get out pretty quickly. And so in this case, you can, just look at how are people using it? How long are those conversations? And so for me, what I went back and my backup to this was, I'm like, okay, now I want to go back into those longer conversations and then look at where they started and where they ended. So those two things together are saying, oh, we know that oftentimes if someone wants to end up here, it takes them a longer time to get there. Again, feeding back into our content insight generation piece that we were using this for. The last one, which is always, the obvious, which is, positive and negative responses to the actual answer that you get. The most interesting thing about this is one, clearly we see, where we've got like different clusters having mostly good or mostly bad ratings. One of the things that we found is that in certain clusters, there was actually outdated documentation, or it was referring to an older version of something. So it allowed us to go in and say, oh, let's rank by most recent versioning, which we hadn't originally put in. And the other thing is, a lot of times we found that there was like the answer wasn't actually in any of the chunks. And so that sort of like not great answer was because that answer came from a wide spread and it was actually a blind spot for us. So it was an area where we said, oh, we actually don't, that answer doesn't exist in here. So this is another area where we found that we've got a blank space in our documentation or in what we've got in the RAG data set that we then want to add in. So again, really simple things like your feedback loop, when you start to put them in this larger context, can really be helpful in managing again at scale. Obviously, using the graph helps you with explainability. Where did that answer come from? What was it related to? Visualizing conversations, understanding your applications. And so, there's lots of ways to leverage a graph. What I like about this particular instance is that you don't have to rip and replace whatever you've already done with your RAG application, but by tracking it in this new way, you actually have a whole new layer of insight into what you've built, what's in your current RAG data set, and how you can leverage that to move things forward. I know we are at time, so I just want to thank you so much for your time and attention today. We've got a couple of QRs. Graph Academy, if you want to learn more about Neo4j. On the right, it was just released yesterday, a new course on deep learning, Andrew Ng's Deep Learning AI, about agentic knowledge graph construction. I know Andreas was talking about that a little bit. So